Welcome to our class of chemistry. Today we study on the chemistry practical. Topic on this session is volumetric analysis. Before looking on the real practical or real experiments, we will start with a briefly on the theory of volumetric analysis. To understand more this lesson, be aware, listen carefully, and prepare your notebook to take a note for anything which are important within this lesson. We are together. Okay. Let's go to our theory of volumetric analysis. In this session, you will see and understand on the following. 1. You will understand on the concept of volumetric analysis. 2. Titration. 3. Ending point. 4. Indicator. 5. Color changes of indicator in acid and in base. 6. Trace of indicator or indicator suitability during acid and base titration. Okay, now also we are together. Theory of volumetric analysis. Volumetric analysis is a chemical procedure of determining the accurate volumes and the concentration of reacting solutions. Titration. Volumetric analysis is performed through titrations. So, in that case, titration is a method of performing volumetric analysis. And then, titration, you can say, is a process of determining the concentration of a substance in a solution by adding one solution to another solution between acid and alkaline or base until a reaction of definite and known proportion is completed. Ending point. End point is the stage where the acid and the base have reacted completely. End point for neutralization reaction is indicated by the color changes observed. What is indicator? Indicator is the substance that gives different color in acidic and alkaline media. Indicator is a chemical substance which shows the color change at the end of chemical reaction. Significance of indicator during titration. The significance of indicator during titration is to show the color change at the end point for the chemical reaction, or in other way, the significance of indicator is to show that the reaction has completely reacted. Before looking at the color changes, let's note the following. The reaction of acid and the base form salt and water as the products. The reaction of acid and carbonate form salt, water and carbon dioxide as the products. The reaction of acid and base or alkali solution is called the neutralization reaction, which means within a product there are neither acid nor base. We see the color changes of indicator during acid-base titration. Phenolphthalein indicator in acid is colorless, in base is pink, and in neutral or ending point for titration is colorless. Methyl orange indicator in acid is red or pink, in base is yellow, and in neutral or ending point for titration is orange. Litmus paper blue in acid is red, in base is blue, and in neutral still blue. That litmus paper still blue. Litmus paper which is red, in acid is still red, in base is blue, and in neutral is still red. Let's see the choice of indicator in acid-base titration. Another way you can say indicator suitability. Strong acid against strong base, an indicator may be used. Weak acid, strong base, indicator used is a phenolphthalein indicator. Strong acid against weak base, methyl orange may be used, and the weak acid and weak base, no suitable data, and in that case we haven't any reaction like this. When we carry titration, a suitable indicator has to be chosen according to the properties of a particular acid and base for titrating. Note that phenolphthalein indicator is made up of weak base and would not support weak base. In that case, we are supposed to use methyl orange. And we use methyl orange indicator because methyl orange indicator is made up of weak acid and we do not support weak. So the reaction which has weak acid, we are supposed to use phenolphthalein indicator because methyl orange would not support weak acid. You student, I'm sure you have understood about all we have discussed here. Still learning with me, scientific technologist Mr. Maguru. The coming lesson you will see here. Thank you for listening.